So in the first order phase transition, we had seen that the specific Gibbs free energy remains same or continuous along with temperature and pressure, but the entropy and volume are discontinuous during phase transition, that is their values are different for phase 1 and phase 2. But there is another kind of phase transition, which is second order phase transition, where along with temperature, pressure and Gibbs free energy, entropy and volume also remain same, that is they are continuous. But discontinuities appears in the second order derivative of G. In the first order phase transition, discontinuities occur in the first order derivative of G, which are entropy and volume. But here Gibbs free energy as well as its first order derivatives, that is entropy and volume, remain same, that is they are continuous, but discontinuities appear in the second order derivatives of G, that is in specific heat capacity at constant volume, which is a second order derivative of G through this relation by Cp equals to, we know, T del S del T constant P equal to, now we know S specific entropy is minus del G del T constant P. Okay, so if we replace S with del G del T constant P, we get this relation. So clearly it is a second order derivative of G there. During second order phase transition, the specific heat capacity at constant pressure of first phase 1 will not be equals to specific heat capacity of phase 2. Another quantity which is discontinuous is isobaric volume expansivity, which is alpha denoted by generally by alpha equals to 1 by V del B del T constant P. Now what we'll do, we know V is del G del P constant T, but here what we can do, we can just neglect the here we can write T, here we can write P, the constant terms. Okay, so what we get, 1 by V, in the next step we get 1 by V del square G del T del P, we can neglect this T and P. Okay, so during the second order phase transition, the isobaric volume expansivity of phase 1, which is alpha 1, will not remain same. Its value will change, so it will not be equals to the isobaric volume expansivity of phase 2, which is alpha 2. Now there another quantity which is discontinuous during such transition is isothermal compressibility, which is denoted by beta T equals to minus 1 by V del B del P constant T. Next B, we can replace B with del G del P constant T. Okay, del G del P constant T. So what we get, the second order derivative of G, which is minus 1 by V del square G del P square constant T. So what we can say, as this way there is a discontinuity appears in isothermal compressibility or beta T, we can write its value for phase 1 is not equals to its value for phase 2. So here what we observe, that for second order phase transition, specific Gibbs free energy for phase 1 phase 2 are same, G1 equals to G2, entropy also same, S1 equals to S2, volume is also same, specific volume V1 equals to V2. But where discontinuity appears, for specific heat capacity at constant pressure, isobaric volume expansivity and isothermal compressibility. So what are some examples? As you have seen, there is like a transition from liquid helium 1 to helium 2, and then from normal conductor to superconductor. These are some example of second order phase transition where these conditions are obeyed.